Hello.
Assalamualaikum sir.
Assalamualaikum, sir.
Walaikum
Alaikum sir.
assalam. How are you all?
We are fine,
Fine,
sir.
alhamdulillah, sir.
Okay. So we have just finished uniformly accelerated motion along horizontal direction. Now let's continue free fall, or which is also called motion with gravity. You have learned this particular topic in your class 9th, but there is some limitation over there. I'm giving you some tips regarding this particular calculation. Using that, you will be able to calculate each and every problem. So first, take the point of thrown of a body at any instant to be origin. Take the point of thrown of body to be origin. And on the basis of that particular origin, upward all quantities would be positive, downward all quantities would be negative. Just 1 minute. Okay, let's take the point of thrown to be origin of that particular body. So from that particular origin, upward all quantities would be positive, downward all quantities would be negative. Upward and downward to be negative. Since gravity always acts towards the earth or towards downward direction, so it will be taken as negative in all different conditions. As gravity acts downward, so taken as negative in all cases. And in this whole topic, we are just neglecting air resistance. And next is air resistance is neglected. There would be some problems regarding a body is going with some system like hot air balloon, any aircraft, or any other system. That particular case, object always acquire the velocity of system whose it was upon. Like if you're moving in a car, the speed of car must be equal to speed of you. Otherwise, your position and car position would be different at different instant of time. Okay. So there must be object always acquire velocity of system whose it is upon in that particular given direction in which the system is moving. On knowing these particular limitations, we will be able to calculate each and every problem related to gravity or motion of gravity. As we have discussed in straight line, we are using equation of motion like v is equals to u plus a times of t. Second is s is equals to ut plus half a t square. Third is b square is equals to u square plus 2as. And last is Snf is equals to u plus a over 2 times 2n minus 1. In this particular condition, we just transform this equation to be acceleration would be minus of g, displacement would be plus or minus of h, depending upon our origin to be in positive or negative. And in all the different cases remains same. Okay. Is it clear to everyone? These points?
Yes, sir.
Yes, sir.
Just write it down. I'm giving you some problems and I'm using these type of concepts over there. Have you all written?
Yes, sir.
Salman? Hiba, have you written?
Done, sir.
Okay. There is some more limitation in this particular motion of gravity. Let's say we have surface of Earth, from this point, if I'm throwing a ball in upward direction, let's say at some initial velocity u, it will move along this direction, and from the highest point, it will return back to the surface of Earth again, so that it will hit the surface of Earth at some velocity v. During its entire motion, at highest point, ball would momentarily stop for a while and then its direction gets reversed. For that instant of time, we take final velocity of the body at the highest point to be zero. So velocity of each object at its highest point would be zero. But at this point as well, object would be accelerating in downward direction with some acceleration g. So some may ask you, define a position where acceleration of body would not be equals to zero, but velocity of the body would be zero. So we'll call it as at highest point of motion under gravity or free fall. Okay.
Yes, sir.
There's the next point. Suppose body takes from this point to this point some time, let's say it is called time of ascent, ongoing from bottom of the surface of the Earth to the highest point. Similarly, it will take some time to descend from its highest point to the ground. Since air resistance is neglected, so by symmetry, time of ascent and time of descent should be equal. So first, time of ascent and time of descent should be equal. The total time elapsed by the body for its entire motion is called time of flight. Time of flight is total time of journey for body is called time of flight. So we can say time of flight is equals to time of ascent plus time of descent. As these two quantities are equal, so it will be 2 times of time of ascent or 2 times time descent is equals to time of flight. Okay.
Yes, sir.
Salman, any doubt?
No, sir.
Okay. There is third relation. By symmetry, if I draw any horizontal line to any of the point like this. So velocity of the body while going up at this instant would be, say, v1. Similarly, velocity at this particular instant while going downward is v2. So I call it as at same horizontal position, velocity of body in either of its direction would be same. In magnitude, but not in direction. So we call it as mod of v1 and mod of v2. Okay. Just write this whole.
Excuse me, sir.
Yes.
What does T stand for?
Which t? This t?
Yes, sir.
Time of flight. This is time of ascent, so we call it as TA, and this is time of descent, we call it as T. Have you all written?
Yes, sir.
Yes, sir.
Salman?
No, sir.
Yes, sir.
Okay. I'm giving you first example.
Sir, can you 1 minute show the last slide again?
This one or the previous one?
Sir, this one. Okay, sir. Taken.
Have you written this?
Yes, sir.
Okay. Suppose a player throws a ball upward at some initial velocity and catch it after 4 seconds. Find first initial velocity of throw, second maximum height it will attain, I'm giving you some clue regarding how to solve this particular problem. As we have just discussed in last part, suppose this is your surface, that is surface of Earth. And in this particular problem, a ball is thrown upward by any player. Suppose this is your ball. It is thrown at some initial velocity u. In any of the problem, just try to define origin to be point of thrown of body. So at this point, take this to be origin. So upward, all quantities will be positive along this direction till its highest point. Suppose this is your highest point. Is it clear?
Yes, sir.
Yes, sir.
Height in this particular condition would be positive or negative. The height covered by the ball during its upward motion.
Positive.
Positive.
Good. So in this particular situation, S is positive of H. Highest point, velocity would be
0.
0.
good. U in upward direction would be positive. And acceleration, G would be negative or positive?
Negative.
Negative, as gravity always acts in downward direction. So we take acceleration to be minus G. Take this particular to be minus of 10 meter per second square. So we have final velocity to be 0, initial velocity is unknown to be u, and the acceleration going from this point to this point is g. So by using first equation of motion, v is equals to u plus at, we will be able to calculate time to going from this point to this point. But in this particular problem, a player throws the ball in upward direction and catch it after 4 seconds. So the total time interval for the entire of its motion would be 4 seconds, or we'll call it simply as time of flight of the ball is 4 seconds. Is it right?
Yes, sir.
Yes,
so by
sir.
knowing so by knowing this particular time of flight, we will be able to calculate time of ascent or time of descent. Time of ascent is nothing but half of time of flight. So it will be 2 times of this. Okay.
Yes, sir.
So now we have final velocity, we have time taken, and we have acceleration. Just put all the values in this particular equation and you will be able to calculate u from this particular one. Okay. Just try to
Yes, sir.
solve. Okay. Hiba, any doubt?
No, sir.
Okay, Hamza, check your unit. It would be meter per second.
Yes, sir. I forgot to write.
Okay. Khalid, have you solved
Yes, sir.
your answer?
20 meter per second.
Hiba? Salman, send me your answer. Okay. So we have done first part. Now we have to calculate maximum height attained by the body. As we have discussed in our last part, this particular equation is called velocity time relation. Using this, we will be able to calculate either of velocity or time. This is called displacement time relation. This is called velocity displacement relation. Okay. So in this particular part, we have to calculate maximum height. Either you will use time, or you use second equation of motion, or using third equation of motion, you will be able to calculate height. Just use second equation of motion. In place of s, use h is equals to ut. Acceleration will be minus of g, so it will be minus of half gt square. As we have u and t and g, on putting all these values, we will be able to calculate height. Okay. Good, Khalid. Salman, Hamza, check your calculation. I have already taken g to be negative. Okay. So just put 10 in this particular place. Send your answer. Hiba, have you solved? Let me help you. we have u as 20 meter per second as we have calculated from first part. So u is equals to 20. Time taken while going up is 2 seconds minus half g is 10 and time taken is 2 squared. So it will be 20 into 2, 40 minus 2 into 5. Square root of 2 is 4. So it will be 40 minus 20, which is equals to 20. Okay, Hamza?
Yes, sir.
Iba, any doubt?
No, sir.
There is some another concept, or I'm giving you one more problem. Suppose a ball is thrown at 20 meter per second from a building of height 25 meter. First, find time of flight. First part. Second part is velocity with which ball would hit the ground. I'm giving you some clue regarding this. Let's say we have a building like this. This is your ground. And a ball is thrown from its highest point. From this point, let's say along this direction. So how would be its motion? Whether it continues in upward direction only or it will return back to the ground
It will return back to the ground.
after attaining some height. So it will move like this and it will return back to the ground at this point. So the total time taken for its entire journey is called time of flight. As we have discussed earlier, take the point of thrown of the body at that particular instant of time to be origin. So call it as origin. All upward quantity from this particular point would be positive and all downward quantities from this particular point would be negative. Okay.
Yes, sir.
So we have two different heights from this particular reference. Let's say this is your highest point. If someone asks you, find height maximum attained by this particular body. So it will be h in this particular direction from this point to this point. So velocity at this particular instant would be 0 at its highest point. So we have initial velocity in upward direction. So u would be positive in this particular situation. Height would be positive in this particular situation. And acceleration means gravity would be negative for this particular part. Okay. I have
Yes, sir.
just discussed this particular section only for upward motion from this point to this point only. Okay. Now, for the next section, for its downward motion to the ground, take the point of thrown to the origin. Upward, all quantities would be positive. So u would be positive in this particular situation. As gravity always acts towards downward direction, so acceleration would be negative. Height, which means the displacement from or the height of building from which the ball was thrown. Let's call it as capital H from this point to this point. what will be assigned for this particular capital H, positive or negative?
Negative.
As origin is at this point, so all upward measurement will be positive and all downward measurement would be negative. So in this particular situation, capital H would be negative. Okay,
Yes, sir.
Eva, any doubt?
No, sir.
Okay, so now for time of flight, just use second equation of motion and apply these particular term and try to obtain time from that particular equation. Okay. Khalid, any doubt? Salman?
No, sir.
Hamza, any doubt while solving? Khalid?
Sir, for time of flight, first we have to find the height, right?
Height is given in this particular question as 25 meter. The height of building means capital H. So just use second equation of motion. S is equal to ut plus half at square. We have S to be minus of H, U to be positive 20 meter per second, and A to be minus of gravity, which is minus of 10 meter per second square. Okay.
Okay, sir.
Iba, in doubt?
No, sir.
Yes, Hamza, send me your answer. Khalid, have you solved? On solving this particular equation, you would finally come to a point where quadratic equation will be obtained. I think there is some mistake in calculation, Hamza. In this particular situation, S is displacement, that is capital H, and capital is 25 meters. So just put minus 25 is equals to initial velocity 20 into t minus half gravity is 10 times t squared. So this will becomes 5 minus of 25 is equals to 20t minus of 5t squared. Just try to simplify this particular whole equation by dividing each part by 5. So it would be minus of 5, 4 times of t, and minus of t squared. Have you all obtained this particular part? Iba,
Yes, sir.
have you obtained this particular part?
Yes, sir.
So how to solve this particular part? Just try to convert or try to bring all part to one side. So it will be like t squared minus of 4t and minus of 5 to be 0. This particular equation has highest power as 2. So it is called quadratic equation. Okay, Hamza,
Yes, sir.
how to solve any quadratic equation? Either you use by middle term splitting or use just formula to solve this. Khalid,
Yes, sir.
how to proceed from this part?
Sir, we can use middle term, splitting middle
Middle
term.
term splitting. Okay, good. So how to split this particular part?
Positive 1t and minus 5t.
Good. So it will be minus of 5t plus of t minus 5 and t squared is equals to 0. Just take out common t from this particular part and take out common 1 from this particular part, and you will definitely get the result. Anyone have doubt in this particular situation how I have just splitted this middle section?
No, sir.
Okay, so if I have taken this particular t as common, so it will be t minus 5 plus 1 in common, so it will be t minus 5 is equals to 0. T minus 5 is common from both terms, so it will be t minus 5 and t plus 1 is equals to 0. Put each term individually to be 0 and their product is 0, so it will be t minus 5 is equals to 0. So t is equals to 5 seconds. For the next part, t plus 1 is equals to 0, so t would be minus 1 second. As time can never be negative, so we drop this. So your answer would be just 5 seconds. Hiba, any doubt? Hamza,
No, sir.
No, sir.
Salman,
No, sir.
Okay. So we have time of flight. Just use this particular time in first equation of motion and try to find the second part, the final velocity with which the ball will hit the ground at this particular instant. Let's call it as B. Khalid, check your calculation. I'm not asking about this particular velocity. I'm asking for this one, the velocity with which it will hit the ground. Use first equation of motion. We have u to be positive 20 meter per second, gravity to be minus 10 meter per second square, and time of flight is 5 seconds. Put all these values in first equation of motion and try to solve for v. Good, Eva. Now it's correct. Hamza? Okay, good. Salman? Okay. There is a question you might have think in this particular part. Suppose initially the ball is thrown in upward direction. So all quantities would be positive for this particular section. And we are just considering for this part only. But on using this particular equation, I have taken for the entire journey. Okay. So by knowing just only this particular initial segment, we will be able to calculate all of the whole segment. We don't bother about whether the body would be going only in upward direction, whether it will return back or not. Just take the initial condition to be whatever the quantity would be, whether it would be in upward direction, whether it would be in downward direction, depending upon that particular situation, assign their polarity to be positive or negative. Okay. Hamza, any doubt?
No, sir.
I'm giving you one more problem. a ball is thrown downward at 30 meters per second from a building. It hits the ground at 80 meters per second. Find height of building and time of flight. Try to solve. Just initially try to figure out all the given condition, and on the basis of that particular origin, define their polarity for u, v, acceleration on all of the quantities.
Excuse me, sir. What is that? It hits the ground at
80 meters per second. Means final velocity of hitting the
oh,
ground is 80 meters per second. We have initial velocity, we have final velocity. So just use third equation of motion and try to find height of building. Should I give you some clue? Hamza? Should I
Yes,
help?
sir. Yes, sir.
Just take this particular as your building. Since the ball is thrown in downward direction, so this is your ball which is going in downward direction. Take this point to be origin, like this. So all other quantity in upward direction would be positive, downward direction would be negative. And this particular situation, let height of the building is in downward from this particular origin. Initial velocity is in also in downward direction, And acceleration due to gravity is also in downward direction. Final velocity on hitting the ground is also in downward direction. So all these quantity is in downward direction, so it will be negative. Okay.
Yes, sir.
So we have u is equals to minus of 30 meter per second. V is equals to minus of 80 meter per second. Acceleration is minus of g, which is equals to 10 meter per second square. So use these values in third equation of motion and try to find h. And similarly, by using first equation of motion, you'd be able to calculate time of flight of body. Correct, Khalid. Eba, send your answer. Hamza, just 1 minute. Good. Find time. Just use first equation of motion. Good. Have you solved? Okay, good. Salman, any doubt?
No, sir.
Okay. There is some another concept regarding this particular gravity. First, dropping of a body. Body may be dropped from any stationary body or it may be dropped from any moving body. Like, suppose if there is a building and a body is dropped from this particular part. So object always acquires the velocity of system whose it is a part. Since the building is in a stationary position, so initial velocity of this particular body for this particular situation would be 0, as this building is not moving. Okay. Now suppose if you have a hot air balloon like this, which is ascending upward at some velocity. So this is your hot air balloon, just assume, and there is a ball or a body in this particular part like this. This particular balloon is ascending upward at some initial velocity u, and at any particular instant of height, let this particular body is dropped from this particular system to this point. Whether this particular body would go in upward direction or downward direction. Hamza? On just dropping this particular body outward from this system, whether this particular body would go upward direction or downward direction.
Or downward.
Khalid? Hiba?
So downwards.
As we have discussed earlier, as all object, if it is moving in a system, it must acquire the velocity of system whose it is a part. So this particular ball is initially a part of this particular system. Okay, Hamza?
Yes, sir.
And this particular system is going up at this particular velocity u. So at this particular instant of time or position, this particular body would also have a velocity in upward direction initially.
Yes, sir.
So on just dropping it in outer surrounding, it must have a velocity u in upward direction. Since this particular body was a part of this particular system which was going in upward direction. Okay.
Yes, sir.
So by the use of this particular velocity, this particular ball or body would go upward to some extent, and then it will return back to the ground. Okay, Hiba?
Yes,
Is it
sir.
clear?
Yes, sir.
Okay. So as I have said earlier, take the point of thrown of body to be origin. So it would be regarded as origin. All upward quantity would be positive and all downward quantity in this particular situation would be negative. Let the height at which the ball is dropped from this particular system is h. Gravity always acts in downward direction. Gravity g is negative and u is positive. So u in this particular situation will be positive, height in this particular situation will be negative, and acceleration in this particular situation will be negative. Okay, Khalid? Hamza?
Yes, sir.
What would be the velocity, height, or acceleration for this particular condition? Let's say height of building is h and acceleration due to gravity in this particular direction. So from this particular point to be origin, u is 0, and is it dropped from any stationary system? Height from this particular origin is in downward direction, so height would be negative and acceleration would be negative. Okay,
Yes, sir.
any doubt, Hiba?
No, sir.
Just write them down. Salman, any doubt? Khalid,
Yes, sir.
any doubt regarding this particular concept?
No, sir.
Have you all written?
Yes, sir.
Yes, sir.
Yes, sir.
I'm giving you one problem. Let a hot air balloon is ascending at 12 meters per second at 65 meters above the ground. It drops a ball. Find time of flight and velocity with which it will hit the ground. Try to solve.
Sir, is the acceleration 12 meter per second?
Acceleration. This is initial velocity of the hot air balloon. In all of the cases, take acceleration to be gravity, which is 10 meter per second square, or if it is mentioned in this particular problem, to be taken as 9.8.
Okay, sir.
Here the balloon is ascending upward direction with this much amount of velocity. As we have earlier discussed in this particular section, let u be the velocity with which the balloon was going upward. So on comparing the question, u is positive 12 meter per second. Height at which the ball is dropped is 65. Take this particular point to be origin, so height would be negative of 65 meter. And acceleration to the gravity in all situation would be negative 10. Iba, any doubt?
No, sir.
Khalid, have you saw it?
Sir, I got stuck.
Okay, I think in middle terms pretty. Yeah.
Yes, sir.
Hamza?
Sir, I am doing. If I get stuck, I will tell.
Iba?
Sir, I'm
Let me
doing.
solve. Okay, okay. In this particular problem, S is minus of 65. So you just use S is equals to ut plus half at square, as S is minus of h, which is equals to a minus of 65 meter. Initial velocity is in upward direction, so it will be taken as plus 12 meter per second square. And acceleration is always taken as minus of g or minus of 10 meter per second square. Putting all these values in this particular equation, it will be minus of 65 u into t minus half 10 t square, 2 into 5 times. So it will be minus of 65 is equals to 12t minus 5t square. Bring all these terms to left hand side. So it will be 5t square minus 12t and minus of 65 would be 0. I think you all have got this particular relation. Okay, Hamza?
Yes, sir.
So how to split this particular middle part? There is some rules. Just multiply this particular coefficient with a constant part. So it will be 5 times 65. Take this particular term or take factor of this particular term. So it will be 5. Split this particular part as factor. So it will be 5 times 13. I'll rearrange this particular factor to get the middle part. It would be like 5 into 5 and 13. So it will be nothing but 25 and 13. Since 12 is in negative sign, so larger number would be negative and a smaller number would be in positive. This will gives you 12. Okay, Khalid?
Yes, sir.
Or you may use quadratic formula. X is equals to minus of b plus minus under root of b square minus 4ac over 2 times of a. In this particular expression, b is coefficient of t, a is coefficient of t square, and c is constant part. You can directly solve any of the quadratic equation using this. Now proceed. Salman, okay, Salman, try to solve or try to proceed using this particular middle terms. Hamza, have you solved?
Sir, almost.
Eba,
Yes, sir. Last part.
okay.
Sir, I got it.
Yes, send your answer. Okay, find velocity. Salman, send me your answer. If you split this particular part like this way, it would be 5t squared minus 25t plus 13t minus 65 is equals to 0. Take 5t common in these two parts, so it will be 5 times t. So left part is t minus 5 plus 13 being common, so it will be t minus 5. T minus 5 is common from either term, so it will be t minus 5 times 5t plus 13 is equals to 0. On solving or on putting each term equals to 0, it will be t is equals to 5 seconds from the first part and t is equals to minus of 13 over 5 seconds for the second part. At time can never be negative, so it will be neglected. So your answer would be just 5 seconds. Okay, Ba, is it the similar one as we have obtained?
Yes, sir.
Okay. Just use first equation of motion. We have initial velocity, we have acceleration, and we have time. Try to find final velocity with which the ball will hit the ground. Okay. Hamza, check your signs. Sign of U, sign of G. We have U is equals to plus 12 meter per second. Acceleration is minus of 10 meter per second square, and time is just 5 seconds. So use first equation of motion. V is equals to U plus A. Good, Ba. Here in this particular equation. Okay, now it's correct. Okay, so all I have done. So we have just finished this particular part. Now there will be a question regarding two different balls or two different bodies thrown simultaneously or one after the other or in some relation. So let's motion of two bodies. Suppose if there is a question, a ball is dropped from 100-meter building. At same instant, another ball is thrown upward at 25 meters per second. Find time and height at which they will cross each other. First, write this question. I will explain you how to solve these particular part. All have written?
Yes, sir.
Hiba? Khalid?
Yes, sir.
Khalid, done?
Sir, the question or the answer?
Only the question.
Yes, sir. 1 minute. Almost done. Yes, sir. Done.
Okay. In this question, there is a building, suppose this, of height 100 meters. From this particular building, a ball is dropped from this instant. So it will move like this. Take this point to be origin for this particular part. So u would be 0. Acceleration would be in downward direction. So it will be minus of 10 meter per second square. At the same instant of time, another ball is thrown upward like this. At some initial velocity, u is equals to 25 meter per second square per second. Take this particular point to be origin. So the velocity initially is in upward direction. So it will be positive. Gravity always acts in down direction. So A would be minus of 10 meter per second square. In the question, they are asked, find time at which they will cross each other. Or it may say, time at which they will meet each other. So in that particular section, if two different bodies are just crossing each other or meeting each other, their position and time would be equal. Let's say it would be some point at this particular instant. So the time taken by this particular ball to go from this point to this point, like this. Similarly, time taken by this particular ball to go from this point to this point, they would be equal, as they have started initially at the same instant of time. Okay, is it clear?
Yes, sir.
Yes, sir.
Or simply just assume if two different individuals meet, so that particular instant of time for either of them would be same. Okay, similarly, the position at which the two individuals get meeting would be remain same, so that they would face each other or cross each other or they meet each other. Okay,
Yes, sir.
so at this particular position, their time would be equal and their displacement would be equal. So from either of the references, let's say first ball is going from this point to this point, call it as x in downward direction. As total height of the building is 100 meters. So the height covered by this particular ball from going this point to this point would be 100 minus x meter in upward direction. Is it correct?
Yes, sir.
Now, for time taken by this particular ball to go from this point to this point would be t. Similarly, time taken by this particular ball to go from this point to this point would be t. Just use second equation of motion for either of the two different balls, and we have two different equations. Just solve that particular part and try to obtain time from either. And on putting that particular time in either the equation, you would find x or position of that particular ball. Okay, Khalid?
Sir, what do we have to do after finding time again?
Just put the value of time in either of the equation to find x, the position of
Okay, sir.
meeting. Salman, any doubt? Okay. Any doubt while forming equation for either of the ball? Ball as it is going downward, so x would be negative, u is 0, minus half, acceleration is 10, and t squared. So this would be your first equation. For the second ball, as it is going in upward direction, so height would be positive. So 100 minus x is equals to initial velocity is in positive direction minus gravity is in downward direction times t squared. Just subtract these two equations simply.
Sir, won't it be 0t?
T is equals to 0.
No, sir. In the first equation, it will be 0t or just simply t.
0 multiplied with any number would be 0.
Yes, sir.
Okay. Simply subtract these two equations or put the value of x from the first part in the second equation. In either of the two cases, you will be able to find t. Khalid,
Yes, sir.
have we done?
No, sir.
Okay. Salman, Hiba, have you solved?
No, sir.
Okay. Try to subtract these two equations. For subtraction, just draw a line, change the sign of each term because on subtraction, sign changes. So here 100 is in plus, so it would be minus, minus, so it would be plus, plus, it would be minus, minus, it would be plus. Now, in first part, here x is in negative, but in this part, x is in positive. So this x and x will cancel out. Similarly, this is half 10t square is in negative and half 10t square is in positive. So this term and this term would cancel out. So what will left with? Minus of 100 is equals to minus of 25t. Minus and minus gets cancelled out. So the 100 over 25 is equals to 4. Hamza, any doubt?
No, sir.
Hiba,
No, sir.
any doubt while solving by this particular way? Salman,
No, sir.
okay. Just put the value of this particular t in either of the two equations to obtain position or the height at which the two balls would meet or cross each other. Your answer is correct, Khalid.
Okay, sir.
Okay, Salman. Just put this particular value of t to be 4 seconds in first equation. Hamza, done. Hiba? Put this particular t in first equation, so it would be minus of x is equals to minus and minus gets cancelled out, so x would be Hamza.
Yeah, sir. I got it. It will be positive.
T is equals to 4 seconds. So 2 5s minus minus cancel out. So x would be 5 times 4 4 16 50 meter. So from top it is at 80 meter, or from bottom it is just 20 meter. Okay, Hiba?
Yes, sir.
Okay. I'm giving you one more problem related to this. Suppose from a building of height 80 meters, a ball is dropped. After 1 second, a ball is thrown downward at you, such that both will hit the ground at same instant. Find u. Try to solve this particular part on its own. Here we have two different balls. First ball is just dropped, and the second ball is being thrown downward at some initial velocity u. So for first ball, it is just dropped. So take u to be 0. Acceleration is down direction, so minus of 10 meter per second square. And height is in also down direction. So h is equals to minus of 80 meter. By using these terms, try to find time. For the second ball, they have given information as this particular ball is thrown just after 1 second of this particular first ball is being dropped at some initial velocity u. So u would be in downward direction, or we have to calculate this particular part. Acceleration in this particular part would also be 10 meter per second square. Height would be remain same, but the time for this particular part would be just t minus 1 seconds. Okay, Khalid.
Yes, sir.
So just try to solve for the first part first, for this part, and try to obtain t. Just put this particular value of t in this particular second equation, and from there try to find u. Use second equation of motion, as we have height and time relation. Hamza, any doubt?
No, sir.
Okay. Any doubt?
No, sir.
Khalid, first part is done.
No, sir.
Hamza? Good, Hiba. Just put this particular value in the second equation and try to find u. Good. Salman, have you solved first part? Okay. Khalid, your first answer is correct. Check your calculation for the second part. In the second part, just take time to be t minus 1 second. Hamza, have we done second part?
Sir, almost done.
Okay. Salman? Iba?
Sir, just the last part. Okay. I'm not confirmed about that particular answer. Let me check. Okay. For the first part, S is equals to UT minus half G T square. So it will be 5 times minus minus gets cancelled out. So T square is equals to 80 divided by 5, which is equals to 16, or T is simply 4 seconds. Just put this particular value in the second part. So S is equals to U in downward direction, or let's say U into T. T is T minus 1, that is 3, minus half G is 10, and T is just 3 squared. So it will be 5. So minus of 80, 3 times of U, 3 3 is a 9, 5 is a 45. So 3 times of U would be minus of 80 and plus of 45. So it would be minus of 35. So u is equals to minus 35 divided by 3. It would be 11.67 meter per second. Khalid,
Yes, sir.
what was your answer for you? Check your calculation. Khalid, you have done wrong at this particular section. You
No, sir. I
subtract.
forgot to take 4 minus 1 in U part.
Okay. Hiba, check your calculation. Hamza, you also. Salman, you got the same answer? Okay, good. Hamza,
Yes, sir.
have you checked your calculation?
Yes, sir. I did the mistake in minus 80.
Okay, okay. Hiba,
Yes,
you
sir.
have done same step?
Yes, sir.
Okay. Is everything clear to all of
Yes,
you?
sir.
Yes, sir.
Okay. So we have just finished all related problems related to motion or gravity or free fall. Using this particular concept, you would be able to calculate all of the various problems from different tips you like. There is one topic left, which is called Galileo's odd number relation, just a ratio. I will proceed it in next class. And next class we'll just start uniformly, means non-uniformly accelerated motion, or the motion in which velocity, displacement, and acceleration is time-dependent, position-dependent function. Okay.
Yes,
Okay,
sir.
sir.